Okay, so tonight I would like to go with the most difficult one, applied SEM for academic research. We will learn from the basic concept, and then after that we go to the practical applications. Okay. Okay, so now everyone, in order to learn SEM, you cannot jump. Oh, I want to learn SEM, then I go to SEM directly. No, you have to understand step by step. The first, you have to understand correlation analysis, then multiple linear regression, then factor analysis, then the structural equation modeling. Then this is actually the you know the story, the comprehensive, the philosophy. Okay, why we use the SEM. Okay, because later on people like use like, oh, why you use SEM? Why don't you use multiple linear regression? You know, there are some cases that you have to use SEM. There are some cases that you only can use the multiple linear regression is quite okay. 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 Now, sorry. This is actually the correlation analysis. Okay. This is one of my publications about the eye movement. Okay, it's actually the movement of the eye. Okay, the movement of the eye. I use because my specialty is actually human factors and ergonomics. Okay, then I published several papers with the eye movement. But here, what I would like to say is not about that, but I would like to say, look at this table, everyone. When you would like to show the interaction between one variable with another variable, show it in a triangle like this one. Okay, because if you use Minitab, you use SPSS, it will be like a double triangle, but you just have to remove one, one side. And you can just show the mean, standard deviations, and the range. Okay, and then this is actually the correlation. This is the basic that later on when you can see something like this one, oh, there are some variables in here, then you can play around with this variable if there is a correlation like this one, the Pearson correlation. You can do, oh, if there is correlation, then you can go to the next one, multiple linear regression, factor analysis, or SEM. If in here nothing is significant, then don't try to go to the next one because the next one will be even worse. Okay, if everything in here not significant, you try multiple linear regression, then the result will not be good. Okay, so I always try to see from the this one first. Okay, now this is the very basic. Everyone knows about the correlation. Now we go to the multiple linear regression. Okay, listen to me very carefully. Now, in a simple linear regression, this is very simple, right? Everybody knows this one. Now, may I ask, B0, Bufuji, what is B0? B0, what is B0? If this is the equation.
B0, that is a coefficient.
Yeah, but what is that mean?
Sorry, that is a constanta.
Yes. Yes. Another one. I want to have the real answer. Pak Handy, this is what? This is what? B0 is what? Or Glycina, Buglycina. What is B0? Don't worry. We just start from the super basic, right? Everyone, B0. What is B0? No? Pak Handy? No? B0. B0, okay, Bufuji. Yes, it's like something you can say like, oh, that is just the one constant value. But this constant value means here, from here, the y-axis, this is what we call intercept. Okay, this is B0. Okay, this is B0. Okay, Bufuji, this value is actually B0. Okay, so this is B0 plus B1. B1 is the coefficient, right? And X1 is just the variable. Okay, now may I ask, B0 can be positive, it can be negative or not, Bufuji? This can be negative or not?
B0 can be positive and negative.
Yes. If negative, look at this one, the blue, right? If you project this one in the y-axis, the perpendicular will be in here, right? The perpendicular, it will be in here, around here, right? If you project this one, then it will be what? Negative, right? It will be negative, right? In here, right?
Okay.
Yeah, right? Okay, so that is actually B0, okay? Now everybody knows what is B0. That is what we call intercept in the y-axis. You try to project that one in the y-axis, okay? So that is actually the B0. Now, multiple linear regression, if you have more than that, for example, let's say, okay, the y in here is actually, let's say the grip strength, okay, the strength of the hand, okay, the strength of the hand. This one, x1, is actually the gender. X2, let's say the height, how tall you are, you know, the height, okay, the gender, and this one, you know, how tall you are, okay. So if you have more and more variables, yes, you can predict the grip strength. But what is the limitation of the multiple linear regression? There are two limitations very obvious. The first one, can you let me ask Pak Friska. Pak Friska, okay. Pak Friska, can I ask you? Okay, now in here, if you have like more, if you have more than one, is it possible in here, in independent more than one, is it possible? Pak Friska, is it possible if you have more than one? Or Pak Handy, is it possible if I have like 1,000 and in here, independent?
Very possible, Pak.
Yeah, possible. But here, dependent. Can I have two at the same time?
Yes, you can.
How? How two at the same time? You have to run it twice, right? In SPSS, right? You have to run it. You have to change it a bit, right?
Oh, sorry. For dependent
Yes.
variable, I think you only have one
Yes.
dependent variable.
Very good.
Yeah.
So the limitation, the first one is you only have one dependent at the same time. You cannot predict two in here. You have to rerun it, and you have to do it one by one. Okay, if you have, let's say you have the y, you have 5, then you have to run it 5 times. You have 7, you have to run it 7 times. That's the first limitation of the multiple linear regression. Okay, Bu Fuji, clear? Got it? That's the first limitation. Yeah, right?
Okay, Pak,
Yeah.
clear.
Yeah.
Thank
Now,
you.
the second limitation, okay? X1 and X2, for example, gender and height, you know, how tall you are, okay? Or like gender with the body size, you know, the hand size, let's say the hand size, okay? Is there a correlation between the gender and hand size? Yes, there is. Male always has a bigger than female, you know. I'm not, sorry, Bu Fuji, I'm not saying that, but actually male, we are stronger than female, you know, because that's why in Olympic, you know, you always split, right? Split gender, right? Male and female, because naturally we are different, you know, male and female. I used to be a judo athlete, okay? I used to be a judo athlete, and then, yeah, if you're just sparring with a female, it's different. If you're sparring with male, the grabbing, you know, the grab before they throw is actually very different. Okay, so in here, the second limitation of the multiple linear regression is you cannot correlate this one. You know, for example, this x1 and x2, my x1 can be the y, right? Can be the y in here, right? Pak Handy. If I would like, this one can be dependent, can be, right? If I just switch this one in here, it can be. But you cannot do it simultaneously. You have to do it split one by one, and so on. That's why multiple linear regression is good for predicting, for mathematical modeling. That is the good one. For example, mathematical modeling of blah, 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 blah. Then that is good, usually using multiple linear regression. Okay, but for example, factors affecting blah 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 blah. Now that is actually using SCM usually, because there are so many factors you try to put, you know. So that is the limitation of the multiple linear regression. So everyone, when multiple linear regression is limited only to one dependent variable, and the second one, it cannot analyze the interrelationship among independent variables. Okay, you cannot see whether this one can affect this one. Yeah, can be, you know, can affect, you know. So we don't know using multiple linear regression. You only can use one mathematical equation. Okay, so understand this philosophy first. Don't worry about this one. We will talk about. I think this is not that you know, not that complicated. But I think everyone needs to show when you do the multiple linear regression. If you choose to do multiple linear regression, you have to understand the autocorrelation, the Durbin-Watson, you know, like 1.75 until 2.25. There is positive autocorrelation or negative autocorrelation if it is out of this range. And then we have the multicollinearity. You have to check the VIF value should be lower than 10. Normality, homoscedasticity, and independency. Don't worry, we will talk about this in the week 3. Okay. And last but not the least, I published a conference with the R-square with the 0.247. Now here it is. That is too low. Someone will say like that one. Yes, it can be too low. But everyone, my PhD dissertation, okay, the R-square is only 25%. You know, I use the multiple linear regression for predicting the preference, but it's so complicated, you know, using the actually I try to prove Fitts law, you know, but don't worry, I'll talk about this one when we study 311. Okay, but my R-square is actually very low. But the problem is, if you have R-square low, it does not mean that your research is failed. Okay, that is the thing that I don't know, perhaps people in, I don't know, Indonesia, in Thailand, or in China, but I think so far than I know, in the Philippines, okay, in the past, you know, when they have low R-square, they are kind of like, oh, I don't know, with my research, this is bad and so on. No, you know, my professor published in Q1 with the R-square only 35 or 37. But with that equation, at least, you know, you can tell people some of the significant factors. Okay, so it's all about the, it does not mean that your R-square is low and your research is bad. No, it's not because of that one. Okay, you have to tell people what are the significant factors. Okay, so, and perhaps from that equation, you can tell people that, you know, the next people can actually, you know, the next people can actually try to make it even better. Okay, so don't worry if your R-square is actually quite low. Be brave a little bit. Now, we go to the third step before SCM, okay? The exploratory factor analysis, or the, we call it factor analysis. Now, factor analysis, okay, everyone, we will talk about this one week 4 or week 5, okay? We try to reduce the variable, not try to reduce the people. Again, if you have 200, let's say 2,000 respondents with 20 variables, the one that you would like to reduce is not the 2,000 people. The one that you reduce is the variable. Okay, you remember, if this is the y-axis is the number of respondents, respondents 1, respondent 2, respondent 3 until 2,000. Okay, the x-axis is actually the variable. The one that you reduce is actually the x-axis, not the y-axis. The y-axis, if you try to reduce, that is cluster analysis. Okay, so some students ask me like, sir, what's what you always reduce, right? So cluster is the same with factor analysis. I'm like, then you have to understand the concept first. Okay, what is cluster analysis and what is factor analysis? Factor analysis, you reduce the variable. You don't reduce the number of the respondents, you know, the y-axis, you know. But for the cluster analysis, you reduce the y, the number of the respondents. You group them. Let's say, oh, from this one, you know, we can group into 3. Let's say those who like coffee, let's like me, Tanaton, Pak Hendy, you know, Mr. Lee, for example, you know, you like the, you know, you like the coffee. But the factors, you know, in here is actually we try to reduce the number of the factors. Okay, so later on, it will be like this one. This one, you have so many variables. Let's see this one. Oh, this is so many, you know, from the, you know, usually from the research, you have this kind of data, the hotel data, the refund, the ease of reservation, cleanliness, you know, this is the typical of the social science data and like, I don't know, service data, okay? And then you try to reduce, you know, which one, you know, which one goes to which, how many factors, you know, based on the nature. So in here, you can use the exploratory factor analysis. And this is actually, you can see, some of them is actually, you can group them. This one become one group. This is 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 one group. This is one group. This is, ooh, I don't know for the last one. So you try to reduce how many factors, you know, among this one. Okay, so it's actually a little bit different between the structural equation modeling and the exploratory factor analysis. This one, you try to reduce it based on the nature. Okay, After this one, then you have to give what? The most difficult for this one. Giving the new name in here is actually quite difficult. How will you give the name to cover these things? Ease of reservation, check-in efficiency, cleanliness, amenities, bathroom, overall quality, ambience. How will you name this one? It's difficult. So this is the difficulty, the challenge, if you try to use the factor analysis as your method in your research. Okay, so up to here, before I go to the STM, so far so good, Bu Fuji? So far so good?
Yes, Pak. Yeah, yes, so far so good. But I want to answer.
What? What?
I want to ask.
Ask,
What
yes?
the different? Yes, yes. Sorry, I want to ask about the different explanatory and confirmatory.
Yes, yes.
What
This
the
is I will
difference
answer.
about explanatory?
I will answer this one.
Yes, thank you.
I will answer this one. Okay, okay. Okay. The same question raised by Pak Hendy actually. Pak Hendy actually raised about that one too. Okay. 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 Then I have to answer it now. Okay. So now we call it SEM or confirmatory factor analysis. Okay. SEM, everyone. Some people say that SEM is actually a combination of the factor analysis and multiple linear regression. Let me just show about, okay, forget about this picture first. Let's just go back to the concept, the story. Remember, if I have the multiple linear regression is something like this one, right? You have one Y and you have more than one X, right? More than one independent, right? X1 and X2, right? Pak Hendy, this is very clear, right? Yeah, right? Very clear. Right? But the difference is what? This one. Look at this one. You also would like to see, is there a correlation between X1 and X2 at the same time? See, they actually try to connect this one, you know, at the same time. Okay, but this one, if your model is just like this one, do you need to use the structural equation modeling? Sometimes my students like, you know, the Y is actually only one, and then like the X is actually so many, and then they say like, sure, I do the structural equation modeling. I'm like, yeah, what for? You know, you don't need to. You just use multiple linear regression. It's okay to answer your question, okay? If you only have this is one. But now here it is the problem. If you have the second one, at the same time, you cannot do multiple linear regression. This is the time you use SEM of the structural equation model or the path analysis. Another one, if this is actually just the path analysis, okay? You know, the path analysis in here. Because now you know, X1 is actually has a bigger effect on Y1 or Y2. Later on, you can see from the coefficient in here, okay? X2 has a bigger effect on Y1 or X2 has the bigger on the effect on Y2. You can see the effect, you know, using this one. If using multiple linear regression, you have to do this one, what? Twice. You have to do this one twice if you use the multiple linear regression, okay? But if you use the path analysis like this one, you can just use in one model and you can tell so many different stories. That is the first thing. The first very simple why we use the SEM and why we use the path analysis, or this is just the path analysis, not yet the SEM, okay? So far so good, Bu Fuji, here? Clear? Any
Okay,
questions?
Pak, clear.
Okay.
Thank you.
Okay, now I go to the next one. Now I go to the next one. Nah, this is actually more interesting. Mediation, okay? The mediation. This is why sometimes it is better for us to use the path analysis. For example, okay, in here, X1 goes to Y. For example, you know, let's say it talks about the COVID-19, let's say, okay. Y has no contact with X, but why suddenly Y got positive? It's like, oh, I stay at home all the time. Why I got COVID-19? You know, something like that one. You forget you have your wife or your husband that goes outside and so on, and it's actually goes to you. Okay, so you know, this is some kind of the story that, you know, we call it mediation. Okay, so is there a significant, is there the effect of the X to the Y? Yes. If the X has a positive COVID, meet up with your husband or your wife, and your wife goes home, although you never go outside, you also got COVID-19. So is there effect of X to Y? Yes, there is. Okay, if your model is something like this one, we call it the mediation. Okay, we call it full mediation. You don't go outside. Okay, so that is what we call the full mediation. Okay, if you use multiple linear regression or correlation, let's say correlation. Oh, X is not correlated with Y. Then why we have to do it with X and Y? Yes, it has no correlation with Y, but X and M, there is correlation. And M and Y, there is correlation. So perhaps the correlation, the story is actually the full mediation story. Okay, that's another powerful thing using the SEM. For example, X and M, no connection. X and Y, no connection. But X and M has a connection. M and Y, there is a connection. So perhaps X and Y can be connected. Yes, can be. Okay, you got it? Up to here, this is the full mediation. Okay, or let's say that's something like this one. The flight from the, let's say the flight from Jakarta, no. Let's say flight from the Jakarta to the, let's say Cambodia, okay? To see Cambodia, Siem Reap, for example, Cambodia, okay? Jakarta, there is no direct flight to Cambodia. You have to change to the Kuala Lumpur or Singapore or Thailand, you know, then you can go to the Cambodia, okay? That is actually the full mediation, if something like this one. But this one, let's say Jakarta and Bangkok, is there a direct flight? Yes, there is. With Thai Airways, there is. But I choose Singapore Airlines, you know, because it's cheaper, a little bit cheaper, you know. So transit in Singapore for a while, then, you know, then now I'm in Bangkok for 2 months, actually. I'll go back to the Philippines in May. Okay, I'll go back in the Philippines for a while in May. After that, then I don't know what will happen because it's still COVID, okay? So we can work from anywhere. So this one, this is the full mediation. This is, we call it partial mediation, okay? And path analysis is actually a good or a powerful thing to answer, you know, this kind of flow, okay? Now, I haven't answered those things, okay? So for the confirmatory factor analysis, is something like this one. Let me just show this one. This is one of my publications, okay? For confirmatory factor analysis, or SEM in general, okay, we already decide that this one goes to this one. This variable, it goes to this under this, okay? We already decide this one under this one. This one already decide under this one. If we go back to this one, the exploratory, go back here. We don't know, right? You don't know, right? Which one goes to the which one, right? We don't know, right? About this one, right? We don't know. We only have like, I want to reduce this one based on the Euclidean distance. You know, this is the, later on you can have this value. Oh, this one is actually in one, you know, under one. This one is under this, the next one. This is the third one. This is the fourth one. Okay. The difference is we don't decide this one first if you use exploratory. But if you use SEM or confirmatory, you decide it first. You already decide, you know, like you already decide, you know, this one goes to which one first. You already decide. Is it clear? Is it clear, everyone?
Yes, clear. Thank you.
Let me show you another one. Perhaps I can have one publication that actually can answer even much better. Perhaps, okay, let me check for a while. This one. Yeah, this one. Wait for a while. Okay, let me just make it full screen for a while. Okay. This is actually one island in the Philippines. I've been to this island for 6 times, I think. Yeah, yeah, because of the project. Okay, we call it Marinduque, and it's actually very, I would like to say, face so many natural hazards. But the most one is actually the typhoon. Okay, typhoon, landslide, earthquake, flood, and then volcanic eruption. Okay, and so on. Now, if you have this one. If you have this variable, I have the data. This is actually from 53,000 data. I'm not joking. I'm running this model using 53,344 data. Okay, actually collected by this Bureau of Statistics. It's actually They have a very nice, like data, and I try to make a model based on this 53,000 data. Okay, if you use exploratory factor analysis, okay, you would like to group this one. I have so many. How many? This one, I think I have 4 times 4, 18. Yeah, 18. I have 18. If you use exploratory, you don't know. It's up to them. Up to the computer. Up to the Euclidean distance. Later on they group with what. But for me, I use confirmatory because I already decided first which one goes to which one. For example, this one goes to what we call exposure. This is actually, we call it sensitivity. This one is actually, we call it resilience. So I make the model like this one. Very simple model. Very simple. Okay. And why the name is actually confirmatory factor analysis. There is no X, there is no Y. Everything is just like high degree of correlation. Bu Fuji, don't you see? This is just like correlation, right? Yeah, right? Just like correlation, right?
Yes.
Yeah, right? But this one, I decided first. This is like, oh, this one goes to exposure. This one go to resist. I decided first. That is why we call it confirmatory. You confirm it, whether it is good or not. Later on, we will talk about this one, the value of this one. But this is actually, I confirm it that goes to which one. Okay, clear?
Clear. Thank you.
Very clear, right? Very clear. Okay. Pak Handy, fresh knowledge. Is it clear? Yeah, I think clear. Getting clear.
Okay, thank you.
Yeah. Okay. Now another one. Why the name is like I got attacked. Actually, the name of the journal. I think this one I make it like confirmatory factor analysis. Okay, the name. At the first, actually structural equation modeling, but the reviewer attacked me because like I don't like the term structural equation modeling, because what you do is just confirmatory factor analysis. The different, everyone. If confirmatory factor analysis is there is no X, there is no Y, but it's simply just the same. As simple as that one. Some people they don't like the because in here there is no X, there is no Y. It's just like high degree of correlation, but I try to group them first before I do the correlation. Okay. If you only know the regression or like correlation, you will do what? Average. Usually undergraduate students like that one, right? Oh, sir, you put average, and then we do the correlation. I'm like, no, that's a very bad technique. Okay, you have to learn more in more advanced method. That is actually this one. If you use the, this is the Yoshiki Kurata's paper. He will graduate next. He finished PhD 1.5 years with me. Yeah, so 1.5 years with me. So half Japanese, half Filipino, and then Tanaton, your name is here. Okay, so you have another journal in here. Okay, don't forget to treat me something when we meet up. Joking. Okay, this one. Okay, Bu Fuji. If you use SEM, look at this. There is what? There is X. There is like there is a head of the arrow, right? It's not like double arrow, right? It's like there is X. There is something like there is X. There is Y, right? Can you see clearly in here? That's clear, right? There is a, there is a head of the arrow in here. So Pak Handy, now if you see this one, this is SEM. Okay, there is a, this one, the head, it's not like double arrow like this one. This is just double arrow, right? Yeah, this is double arrow. So yeah, this is so ugly actually. I created this one in, keep it secret, okay? I create this one in the Microsoft PowerPoint. I create this one in Microsoft PowerPoint, okay? But this is my student from the IO Draw. Yeah, I think he used IO Draw. Okay, sorry, I was so lazy that time. So I created this one in the mic, in the PPT, okay, because of PowerPoint. Okay, let me go back to this one, okay? Okay, okay, everyone. If you see SEM, you will see a figure like this one. In the structural equation model, you will see this one. There is an oval, there is a square in here. See this one first, the oval and the square. Okay. Okay. For the oval, we call it what? Bu Fuji, how we call it this one? the name of the oval or the circle, you call it this one what?
Academic performance.
Yes, this is what
That
we call
is
what?
Variable.
A variable.
Sorry. The dependent variable.
Another one, not that one. Another one.
Endogenous latent.
Yeah, I already showed this one. No, actually, this one, that what we call latent, okay, or unobserved variable. Okay, everyone. So I will write it in here. Okay, we call it latent or unobserved variable. Okay, not just variable. I mean, what variable? Unobserved variable. What is the meaning unobserved variable? Someone asked me, like, oh, what is unobserved variable? You know? Okay, look at this one. Unobserved variable is you cannot see that directly. For example, this one, understanding of COVID-19. This is, do you have the data of this one? Understanding of COVID-19. Do you have the data in the Excel? No, right, Bu Fuji? You don't have this one, right, in the Excel, right? You don't have this data. The one that you have is this one, right? Likert scale 1 to 5, 1 to 5. You only have this kind of data, right? You don't have this data, right? I understand COVID-19, 1 to 5. No, right? like you don't have this kind of data. You have this data. Another one. Let me show it to you. Another one. Okay. Wait. Let me show it to you. Another one. This one. Let's go back. Just go to the this one. Is there a data or sensitivity? Do I have sensitivity data in here? Like sensitivity, something like that one? No, right? In this one, there is no such data. That's why latent, we call it unobserved variable. Okay, unobserved variable, because you don't have the data of that one. This one, there is no data of this. There is no. But this one is actually being explained by the square. That is what we call observed variable, or we call it what, Tanator? We call it what, Tanator? If you cannot answer that one, I will not let you graduate PhD. What is this one, Tanator? Are you there?
Yogi, sorry. So latent is similar with variable, right? Different.
You can say unobserved variable.
Unobserved variable.
Yes, usually we don't say directly like lat. I don't know, depends on the paper, you know. But we actually try to we say, like, for example, several factors. Yeah, it can be, but usually it's very uncommon. We call it variable. We call it factors is okay, but the variable in the paper, you can say unobserved variable. That is okay. Yeah, because variable, we got confused. If you use SEM, like what variable? You use the observed variable or unobserved variable. Okay, this is what we call indicator. Do you have the data? Of course you have the data. Okay, you have this is, you have the data. Yes, you have the data. If you use Likert scale 1 to 5, for example, I do understand the transmission of COVID-19 1 to 5. Is there the data in your Excel file? Yes, you have the data. Same thing with this one, with my publication. Sensitivity, what is S1? S1 is like senior citizens in the house. How many senior citizens in the house? Do you have the data? There is the data in here. Okay, that is what we call indicator. Okay, this is what we call indicator. Okay, the square like that one, indicator. Now everyone asks me, oh, why don't you show the indicator in here? If I show the indicator in here, the model will be like a what? Like a pad thai, you know, like
Very crowded. Very crowded.
Yes, Tanator, you know, if I imagine, you know, if we put, you know, in here, it will be like a tom yum with so many foods inside. I mean, I don't want to show that one too crowded, you know, in that one. Okay, so when usually, okay, if your model is too complex, you only show the lat, and this one is okay. You know, this is actually is okay, because overall, this is actually what you would like to tell people. Okay. But this one, why I show the indicator? Yeah, the model is so simple. You know, if I only like this tree, it's like 3x. like 3x. I mean, it does not look good. So I think I would like to show this one too. Okay, but if you put this one, like it will be too complicated. Okay, or like if you, for example, this one, this is already complicated. You know, if you see the indicator in here. Okay, or like let me show you. Okay, this one. This one. Is it complicated? Yeah, I think it's going to be complicated if I show the indicator inside. Okay, so I only show the latent. Okay. Now, we have to know there are two things. Okay, this one and this one are two different things. Okay, this value. Now, everyone has to understand this value. This is what we call the factor loading or loading factor, up to you, or lambda. You know, the symbol is actually lambda. Okay, this is actually the beta coefficient, you know, the beta coefficient in the multiple linear regression, just exactly like the multiple linear regression. Okay, so in here, factor loading means how good this indicator represents the latent. How good this indicator represents the latent. Okay, so if the latent is actually, if the value of the factor loading is getting like higher and higher, you know, it means what? It's good. It's a good representation of the latent. For example, in here, academic performance, which one is the best indicator? This one, right? SAT score, right? Okay, and the rest is actually quite good because the factor loading, you know what, everyone? Usually, it is higher than 0.7 is good, but it can be tolerable until 0.5. Some journals say like 0.5 is actually already okay. You can just put it there if it is higher than 0.5. But if it's lower than 0.5, then just remove it. It means it is not a good representation of this latent. Okay, because you said it first, right? For example, this one. Oh, I set this one as the indicator of this latent. Then you check later on the factor loading. Okay. If it is good, higher than 0.7 or like higher than 0.5 is actually quite okay. Okay, if it's higher than 0.5, it's okay. Just keep it there. It's okay, good representation. But if it's lower than 0.5, then it is not a good representation of the model, of this one, of the latent. Is it clear? Pak Hedi, good. Yeah. Okay, Bu Fuji. So far, so good.
Yes, clear. So far,
Very clear.
so good.
Okay,
Thank you.
Okay, next one. Okay. Now, for example, this is 0.64. Yeah, it's okay. Just keep it there. That is still okay. Okay. Now, this one, I don't want everyone, get confused between the beta coefficient and factor loading. I don't want all my students, you say this one factor loading, I'll be like, never say this is a factor loading. Okay, this is the beta coefficient. This is the factor loading. Okay. Because the beta coefficient is actually how good the connection between one latent to another latent, just like in a multiple linear regression. What is the minimum cutoff of this one? There is no minimum cutoff. Check the p-value. Okay, in here. But usually, okay, everyone, I think higher than 0.15, 0.20, I think already significant. Okay, I think high, but you have to check the p-value. Okay, for this one, there is a p-value in the software. There is the p-value. Okay. In order to keep this one, is actually you have to check the p-value. Okay, but this one you can decide it quite quick, you know, because this one like higher than 0.5 is already okay. Okay, Pak Hendy, so far so good. Okay, very good, right? Now another term. Someone say like, oh, this is what? Yeah, if this is, we call it exogenous because there is no latent goes to this one. Is independent. And this is actually endogenous because this is actually affected by another latent. That is what we call endogenous and exogenous. Okay, but that is actually quite okay. For example, this one. This model, it has two latent variables, right? Very simple, only two latents. You know, this one. Wow, got published. How come? Oh, okay. Oops, I'm recording this one, right? I hope the person is not will not watch the recorded video, okay? Otherwise, the person will hate me, okay? Nothing, okay? Anyway, this one, now this is the factor loading, right? So this is very low, like 0.12. You have to remove 0.0. This is not good, not good, not good. This is okay. 0.8, 0.6 is too okay. For 6A, we remove this one. This is okay, not good. Okay, this is okay. So later on, you have to cut the one that is not significant. Okay. Now I'm going to ask this one. Pak Hendy, do you think this one is factor loading or beta coefficient?
Factor loading.
What is the definition of factor loading? The factor loading is how good the indicator represent the latent, right? Usually, okay, the arrow is actually from the latent to the indicator. I forget to say this one. The arrow, the latent to the indicator. But this is, the arrow is actually from the indicator to the latent, right? It's a little bit, this is different with this one, right? You know, the arrow, you know, this latent, it like absorb, you know, it absorb this one, right? But it does not absorb this one, right? You know, the arrow, you know, the arrow in here,
Coefficient, yeah.
Yes. This is actually coefficient. Okay, Bu Fuji, is it clear? This is different.
Clear.
Okay? This is different.
Yes.
Okay. Yes. Okay. So this is actually the still the beta coefficient. Why should you like that one? Yeah, it's okay. It's the researcher's model. You know, you cannot complain. That's the one that they tested in here. Female 1, 2, but later on you have to put the dummy code. Okay, everyone. If your gender, for example, male is 1 or 2, you have to be very careful later on. For example, male is 1, and this is actually positive. Then what is male is 1, female is 2. Then if this is positive, that it means that the female has a bigger impact, something like that. You know, you have to be careful with your dummy code. Okay, so that's why I always ask the student to show me your dummy code. You know, show me your dummy code. Show me your dummy code. I always force everyone to show me the dummy code. Otherwise, I will get mad. You know, like because I don't know, like, this is male or female, or later on you can see another dummy code is actually have insurance or not have insurance. I have that one, another one. So which one has a bigger effect? You know, like that is another one. You have to be careful. Okay. So if it is like this one, you can see this is the latent, this is the indicator. Okay, later on. Okay. If it is like this one, then we can see so if let's say this is the questionnaire. So how many questions? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 questions, you know. And then this has 2 exogenous variable and then 2 endogenous variable. Okay. And for endogenous, everyone, you show this one. Can you see this one? There is a circle in here. This is actually the error. Okay. The error, just like in the multiple linear regression, you know, you always see the error, right? In the end of multiple. This one. Error, you know, like E, you know, for the endogenous, you know. So that is actually the same like this one. Now see, this is endogenous, right? It has the error, right? Because it's affected by this. See, this is the error. Okay, don't worry. Later on in the software, I will start again from the scratch. Okay, from the software. This is understanding the concept, basic concept of the SM. Okay, don't worry, running SEM is easy. You know, I can run in 15 minutes. You know, finish one model. Okay, but you have to understand the basic. Okay, or the philosophy, because this is the doctor of philosophy, right? My professor always asks like, hey, understand the philosophy of the one. Okay. Now, this is more complicated, but I don't think everyone in here likes human factors ergonomics. Actually, I abuse, you know, the concept of the SEM in the eye movement, you know. Not many ergo researchers like me because of I try to abuse the concept of the SEM, you know, but it's okay. I told my professors like, oh, it's okay. You can dislike with my model, you know, but I just try to show my idea. Okay, I got published, you know, it's okay. People respect it. Oh, you can have a different idea, you know, because why this is square? Square is what? It means you have the value, right? If it is square, do you have the value of this one? Yes. This is observed variable. Everything is observed variable here. Okay, but this one is unobserved variable because I put this one together like this. Okay, So you can have a model like this one, but this is purely experimental. I will explain this one in the this Saturday, okay? Don't worry about that. Oh, this one also. We can see the effect of direct, indirect, and total effect. Direct, indirect, and total effect. Okay, this is what we call the mediating mediator. Okay, for example, this one. Index of difficulty with the symptoms. Is there direct effect? No. But is there effect of index of difficulty to the symptoms? Yes. From here, from here, then it goes to, this one, it's like the, the water. It can reach here, right? Yes, it can reach there. Later on, you can see the effect, how big. But of course, if it is not direct, usually the effect is smaller rather than this one, the direct one. Let's say that the, tsunami. Okay, tsunami, this one like goes to, if you have the block, then it would the value will be a little bit smaller. But if it's like direct like this one, the damage or like the effect is actually quite big. Okay. Okay, slowly. Okay. No, this one is actually, I will explain this Saturday. This is very advanced, this one. Okay, now I go to this one. This is if we use this depends on the software, okay? But if this is using the Amos, okay, you will see this one. Some of the indexes that to tell you that whether your model is actually good or your model is actually bad. Okay, so NFI, PLI, and CFI, GFI and AGFI, okay, this value just like the R squared. So if it's close to 1, it's actually good. But again, some researchers try to attack me like, oh, that is your, sometimes, my value is like 0.8 something, it's hard to get 0.9 because it's just a very questionnaire based, okay? Usually it's very difficult and they attack, oh, that value is low, and I say like, oh, some journals also publish that as low. I will attack it back, the reviewers, when they only attack it only from the value. Okay, this one is actually the R square. Okay, this is the R, just like the R square value. Okay, this is just like the garbage, if you check, okay, it should be lower than 0.07. Okay, this is the same, this is the badness, how bad it is, should be as small as possible. This should be as high as possible. But very interesting, everyone, I would like everyone to show this one. This one, look at this one. This is very rare to see, SEM studies showing the p-value for chi-square. Very, very rare. But I am so brave to tell everyone that, hey, look at my model. It's beautiful. Why the p-value higher than 0.05 is good? Is there someone who can answer this? Tanatorn, can you answer? Why the p-value higher than 0.05 is good? Oh, I think he is in the, Tanatorn is in the military. He is in the Air Force. I think you cannot you cannot talk right now. Okay, let me just ask again. Pak Hedi, why do you think why p-value is higher than 0.05 is good? Usually it's very rare to see STM show proud that, oh, this is my p-value. Okay, why I'm so proud in here? But this is the only publication I can show p-value. The rest, I will hide it. Do you know why? Pak Friska, why p-value higher than 0.05 is good for this one? I know.
I think maybe the acceptance area should be
no. The concept like this one. The concept like this one. This is the model. This is your data. The model and the data. Model and the data. Okay. And based on your data, you try to create a model, right? But now you have to see from the p-value. If the p-value is higher than 0.05, what does it mean? What does that mean?
It means that 95 of my model represents the real data or the population.
That's the correct answer, you know. So it means no significant difference between the model and the data. That's why the p-value should be higher than 0.05. It means it's good. Okay, but it's very rare, you know, it's very rare to see something like this one. I ran so many years SEM, and this is the only model that I can show the p-value, because this is experimental base. I use the experimental base, you know, like the IM movement data. There is almost no noise, right? Because you got the data is actually the real, you know, human performance, the real human data, not the questionnaire Likert scale 1 to 5. Okay, if it is Likert scale, you know, Pak Rizka, okay, if it is you know, Likert scale 1 to 5, it's you know, if it's 1 to 5, then usually it's difficult to have this one. So that's why I hide it, you know. But it does not mean that I manipulate my model. No, you know, we become a little bit like politicians. Okay, so researchers sometimes, you know, become politicians. Okay, and then when I review a paper, I always ask, you know, can you show me this p-value? They kind of like they actually know, like, oh, the reviewer is a good reviewer. But of course they will not show it, you know, because we know that they cannot reach that value. Okay, but anyway, as long as you are not faking the data, it's okay, you know. But usually the minimum for the GFI and AGFI higher than 0.8 is already good. Yeah, so it does not need to be like this one. If you see my other publications, higher than 0.8 is okay, but people always say like, oh, that's low, that's low. I'm like, the most important is not the low or high in this one. The most important is like, can you explain your model, and can your model have a big impact? I was like, can you have model have implications on the policy? So that is the thing. It's not like, oh, because your R-squared is low and your model is bad. No, it's not like that, you know. So that is the thing that we have to, you know, be brave, you know, in the doctoral degree program. But of course, if you fake this one, then that is a criminal, you know. But okay. Now, sometimes again, everyone, Pak Rizka, in here, you can see this is square, or like a Bufuji, for example. But you said before, the square is actually for the how is it that? The square is actually for the latent. Sorry, for the indicator, but not the oval or the square is actually for the latent. But why the latent here is the square? Yeah, you can ask the Mr. Al-Amin, you know, you can ask. Usually, okay, everyone, is the oval. Usually it's oval. This one, usually in general, okay. If you make it square like this one, it looks so observed variable. So when you see this one, somehow like confused. If you see the questionnaire, okay, this is the questionnaire. This is the questionnaire. Okay, look at the one. Subjective norm. Is there value subjective norm? No, no value. So subjective norm should be what? Unobserved, right? Latent, right? Latent. It should be latent here. Your government and society, it should be what? Latent, right? Because you cannot see it here. So in here, this should be what? Awful. It should be awful, you know. But if you ask why is it square, yeah, don't ask me. Ask the, you know, the writer, okay? But ask the reviewer, okay? But it's okay. But at least, you know, we understand what this person is actually talking about, okay? This is the factor loading, okay? Oh, it looks beautiful, actually. Yeah, pretty good. Higher than 0.6, I think mostly everyone, okay? And now there is another one. We call it reliability in here, okay? You know, this is what we call the composite reliability, okay? The CR over the composite reliability, okay? So for each of the latent, you can have the value of how reliable that is. Just like a Cronba alpha, you know, but this is actually more advanced than the Cronba alpha, okay, for the composite reliability, okay. But don't worry, everyone, I will teach this one next week. If I teach all of you today, we will not sleep away, and then you have a nightmare tomorrow, you know. I only have 30 minutes left, okay. My class usually like 2 hours or 2.5 hours. You already got headache, okay. If you can stay in my class, there was a time my class for like 3 hours, and everyone kind of like, oh sir, I cannot take it anymore. You know, like I think, you know, my students like, sir, I really cannot. When I explain Fitts law or Hickman's law, very mathematics, you know, very, and everyone is like, oh, I don't like this one. It's like, okay, let's just stop here. You know? because you get the information, too much new information, and then you have to try to, put it in your, mind and in your long-term memory. Okay. Okay, this one. Okay, this is quite unique actually, everyone. This is my publication. Okay, with another one, senior high school. This is just a senior high school student, but only for the conference. This is only for a conference, not for the journal. If you see this one, okay, if the Y is actually like this one, only one, and so what does that mean? Bu Fuji, can you do multiple linear regression with only this one? Yes, right? Because this is only one, like, and then this is observed variable, not unobserved variable. Yeah, right, Bu Fuji?
Yes,
Yeah, right?
that is
Yeah.
a multiple regression.
Yeah.
Correct.
Multiple linear regression is okay, this one. But
Yes.
what I want in here, like, I would like to show this one. I would like to show this one, actually to tell people. But of course, this is just a conference, this is not the, you cannot sell this one to a journal. But I just want to tell the people like this one. Gender has the effect on the grip strength. Of course, male is stronger than female, and so on. But is there effect of like this one? Hand, the hand size? Is there the effect to the grip strength? Yes, there is effect. But I would like to see this one. Gender is actually has the direct and indirect effect. So male, although female, for example, this one, male and female, let's see, male with a female like 180 centimeter, they have the same hand size. Okay, exactly same hand size. But who is still stronger? Male is still stronger, even the same hand size. Okay, so there is the effect of the gender itself. Okay, you know what this is. It means, right? The story of this one. It's very clear, right? Like this one. Although although like male and female has the same hand size, male is still stronger. So what's that mean? So yeah, this is actually telling that one. But of course this is just conference. Okay, so I just want to sell that idea to people. Okay, but of course using the same data, I use the multiple linear regression to another conference. So I have 2 publications from the same data, and then you can get what incentive. Well, we are talking about that one in here, okay? But anyway, yeah, we need to have a better life, okay, with incentive, okay? Anyway, okay. So we have multiple linear regression and the R-square 72, yeah. So this is, I published in another conference, but they're still senior high school and published 2 conference paper. I think they are good enough. Now already in college, these students, okay? Now, yeah, yes, Bu Fuji.
Sorry, what the different multiple linear regression and stepwise multiple linear regression?
Very good, very good. Stepwise, okay. We put the significant one only, book. We don't put all the variables in here. Imagine, book, if you have 1,000 variable, what will happen with your R-square? Your R-square will be higher or lower? If you have 1,000, always higher, right? If you have like putting more and more and more variable, the R-square will be higher, okay? But it not necessarily for the adjusted R-square, okay? The adjusted R-square is actually the more better one, with this one. So stepwise, from that 1,000, they only put the most significant. They only put the most significant. If it is not significant, they will, kick it out from the model. So later on, you will only see in here the most significant variables that affect the grip strength. So that's why that we use stepwise. We will talk about it the 3rd week. Okay, Bu Fuji?
Okay, thank you.
Okay,
clear.
Yeah. Now we talk about the structural equation modeling, okay? So everyone, when you do the structural equation modeling, it is better for everyone to have a strong theoretical background. That's why we always use what theory you use, what model you use, what approach you use. You cannot just put like, oh yeah, I put this one, that one together in one model, and then like yeah, just try to see the connection. People will not like it. Like people will disagree with it. You need to have a strong theoretical background for creating a model. Okay, in SEM, you cannot just put, oh yeah, let me just use the random questionnaire. You cannot do that. Okay, so there are some theories that perhaps I would like to introduce nowadays. Okay. Oh, acceptance of mobile application is actually a good topic nowadays. Okay, but it's already very old-fashioned. I think so many people already done this one. Like the Grab, mobile banking, Gojek, fitness-related, or like COVID-19 contact tracing. There's so many. There's so many mobile applications that nowadays, like trading. Like TikTok. I don't know. I really want to do TikTok substance, but or what else? There are so many mobile application. But the novelty. Be careful with the novelty, okay, everyone, because I think it's already too common nowadays. Okay. So now this is the step. If you would like to conduct a study that related with the structural equation modeling, okay. But don't worry, later on you can combine with a more advanced technique, just like Thanathorn. He after SEM he used the random forest classifier, and then he used the artificial neural network. Okay, using exactly the same data, you can have more and more technique, with the data mining. That's why me myself, during the data mining class, I'm still learning. Nowadays I don't feel shy, like I study with PhD students because I need to learn more advanced method. People in ergonomics, they are going to that direction. Okay, so first thing is that you need to do if you would like to do this kind of study is theory and research gap. Look at this one, theory and research gap. So you have to choose what kind of theory that you use. Either theory of planned behavior, technology acceptance model, UTA, UT2, protection motivation theory, self-determination theory, or like Thanathorn. What else did you use in the past? TAM, UTA, UT2, SUS, right? System usability scale. You can use, yeah.
Hello,
SUS,
sir.
right?
Sorry, I'm here. SUS.
Yeah. SUS.
PMT,
Yeah,
TAM.
PMT. Yeah, TAM. Yeah, those are good theories, that everybody can use. Okay. If you would like to learn more about this one, Dr. Satria, the consumer behavior, the one will teach consumer behavior. He's more expert than me. I mean, my background is just the human factors ergonomics, but he's very expert in this area. Okay, and then you specify your model. Okay, although you already develop, try to construct, based on the theory, but you have to see your model. What is the novelty of your study? What is new? If it is just not new, then why? I'm like, if the model is too boring, and then you feel like, so what? Something like that. For example, let me show it to you, this one. Okay, this one. See the cute face, right? The senior high school students. And this is Dr. Arpin. Okay, he already graduated. Okay, look at that one. The new one is what is what? Integrating protection motivation theory and extended theory of planned behavior. See, from the title, it's very clear. I integrated two theories. Is it new? Yes. Somehow it's new. Okay, because you're afraid of something, it motivates you to do something. You're afraid about the big one. Hey, the big one is going to be very big. The last one in Metro Manila, I think it was like November. I think almost 6. Okay, the big one is actually predicted to be 7.5 exactly in Metro Manila. So, and I live in the 20th floor, my apartment. I'm afraid, somehow when I read about the big one, it's kind of like, oh my God. Then if I live in the 20th floor, then yeah, I might die because of the earthquake. Okay, and I live in the 20th floor. Okay, and then okay, so it's actually the 7.2 is predicted to be exactly in the Metro Manila. Okay. So it's not happened yet, right? So we actually use the theory of planned behavior to see the intention to prepare about what factors actually affecting the intention to prepare for Filipinos, okay, in the Metro Manila, to prepare for the big one. So start with understanding. When you understand about the peak one or know about the peak one, it goes to the perceived vulnerability and perceived severity. You feel vulnerable and you feel severe. And because of that, it goes to a certain behavior. That's why I combine it with the theory of planned behavior. Why you have media? Yeah, why not? Media always posting the big one, the big one will hit the Philippines. Okay. So yeah, this is actually the model. Okay. And then, oh, look at that one. This is the initial one, very complicated, right? If I show it all of you, all the indicators in here, and I remove some of the non-significant indicators. Look at that one, the one with the dot dash line in here. It's actually not significant, so we remove it. Okay, and then we only put with the one with the factor loading higher than 0.5. This is the final model. This is the model fit. Okay, yeah, it's quite okay, like higher than 0.8, everything, or MSCA lower than 0.07, so it's okay. Okay, yes, Pak Friska, what happened? What happened?
Sorry for interrupting, Dr. Yogi. I just curious, how did you choose particular factor that is not influenced so far or so big, and you choose to, and you decided to remove it? How did you do that? Is that given by the model or by the result of the model, or how?
Okay, so the idea of the SEM or confirmatory factor analysis, we would like to confirm our model. We propose a framework and we would like to confirm it. And how we confirm it? Yeah, try to redraw this one, right? Try to draw this one. And then based on this one, it's actually pretty good. Some of the questionnaire in here, I use questionnaire in here, the questionnaire Likert scale. But in order to create this one, I think I miss showing this one. This is actually the creating how to build the research gap. So I read a lot of studies related with the earthquake, and with the earthquake, what theory they use and how many samples, what the conceptual framework they use. Okay, this is actually an example of the mobile banking. Look at this. There is I always use this one, for all of my studies. So I suggest for everyone, starting from now, try to create this one. This is a very powerful, try to create this one. How to create this one? Yeah, by reading. It's not one night work and then you pray and then you got this one. It's slowly, slowly reading one by one. I always make this one. Okay, so I always try the title, the author, what year. Why year is very important? Because relevance is very important. If it's too old, then like perhaps the topic is already too many years ago. Which country? Yeah, perhaps. Do you know why? Which country? Because the country itself can be a research gap. For example, yeah, it's done in other countries, but in your country, perhaps it's a little bit different. For example, in Indonesia, there's the Semeru, okay, eruption, okay? The model will be very different with the eruption that I've done. It will be very different, okay? Or what another disaster in Thailand? I don't know what disaster these days. Fire in Thailand will be different with fire in the Philippines, okay? Oh, the house in the Philippines is just very close to each other. And then if you got fire in barangay is like one community, like one, one, how say that? It's like, one block, community block, then if there's a fire, usually like those, area got fire, like all, okay? So it will be a little bit different, okay? And then the journal itself, perhaps you can be your target, the purpose of the study. And this one is also important. How many respondents? Because people always say like, oh, that's too low respondents, that's too blah, 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 and so on. I don't usually use the minimum number of samples, if you read my papers. And the researchers usually will not attack from that one. Oh, the sample is too low. I'm like, usually for SEM, higher than 300, 400 is already safe. And people don't usually talk about the criticize those small things into making it big. Usually in local, Q&A, usually they ask this one more. Conceptual framework, this is important. Okay, that's why I use the protection motivation theory or theory of planned behavior. Okay, this is, you use what? DMIS success model. I published one paper about this model. Okay, and this is very important. What factors that they use in the paper? So you try to mix and match your own by reading. So that's why I use the protection motivation theory and theory of planned behavior, because it's something like behavior related. And what drives the behavior is actually the protecting behavior. So it's like because you're afraid with the big one. No, I'm afraid to, die. It's like my house 20th floor and it's shaking, and then I can, I don't know, I don't prepare. Then if it really happens, then I might die. So that's why I use that framework. So in order to build that framework, I read journals, and then if you see my questionnaire, everyone, you will see the questionnaire. It will be like let me show it to you, one example of the questionnaire that I have. Perhaps I can show it to you. Wait. Some of my publications that I show the questionnaire. Oh, this one. Let me just show this one. I show it to you like some of the this one. Look at this. Supporting reference. See? Even just one construct, I have several studies to support. Okay, so this one is very strong. That's why the model is good. So far, you know what, everyone, it's so funny that I'm from industrial engineering, but I publish in International Journal of Infectious Diseases. So many doctors got jealous because of like, wow, someone from industrial engineering published in the top, this is a very top, what is that, medical journal actually. But I'm like, I did public health. This is kind of like close to public health, but I'm from human factors. But it does not mean engineer cannot do those things. It's like now everything is the multidisciplinary, so it's fine. And it's funny that this is my best publication so far, including if you see the Google Scholar citation, I think almost 150 for this one. Yeah, it's still new, 2020. So I hope it could reach 1,000 within, I don't know, 3 years, 4 years, hopefully. And those ways, those papers that actually my I would like to say core, the ergo, it's the citation is not, it's just so. So yeah, I don't know. Perhaps doing something related with the health is actually more impactful, I think, yeah, to people. Okay. Is that answered, Pak Fiska?
Great
answer.
Great answer, Dr.
Yeah, okay. Another module. Okay, we have 10 minutes. Okay, so 10 more minutes. Let me just finish this one, the first class. So this is the TAM. Usually this one is awful. Okay, everyone. We have the technology acceptance model. This is very common if you're model related with technology. TAM is actually very common. Okay, mobile application and so on. Usually TAM is actually quite common. Okay. And if you get bored with the TAM, you can use this one, extended TAM. Yeah, you can add more and more variables, by reading more and more papers. Okay, but it does not mean that you say like, oh, this is not a PhD model because it's not complex. I'm like, no. It does not mean that the more complex the better it is. Depends on what you want to tell people. Okay, I've done actually I get lost, when I did one publication with senior high school, and the students like, sir, I would like to put so many variables and so on. Do you know what happened? The model would not run. The model would not run, and eventually, from 20, eventually the one that significant, I can run the model only like 9. So the rest is like useless data. That's why I'm telling. But I know it's just a senior high school study, but I told them like, hey, it's a good study for you. It does not mean the more complex the better. But sir, we published it. We don't care about that one. Like, yeah, the kids very happy, when they have a Q1 journal like that one. Look at this one. Driver's acceptance. So very clear, right? Driver acceptance. So what's that? Usually acceptance. You're just acceptance. Look at the model. See? Just the extended technology acceptance model. Look at this. This is just the original TAM, and they only add 3 latents. Look at this, only 3 latents. And what are the indicators? You can check. Oh, this is the indicators. Okay. I think 1 to 5 Likert scale or 1 to, I don't know, 1 to 7 Likert scale. That's up to them. Okay. So this is the indicators. Okay. And so on. Is it many? No, not many. Is it strong? Very strong. This is from the strong theoretical background. Okay. Another one. Look at this, everyone. Acceptance of mobile library application with extended technology acceptance model. Very simple, you know. In the look at that, the title is so simple. Looking at the title. For example, using Insignia. Oh, this is the name of the software. Using this, my academia would enable me to access blah 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 more quickly. Using this would improve my academic performance. Using it, very simple, right? You're just using this one, and they try to make it a model out of it. Yeah. This is from the theory of learned behavior. You know what makes you another one. This is a framework of the theory of learned behavior. This is like another one, extended theory of learned behavior. You know, you can make like more complex one. Yeah, it can be, you know, but don't be too complex. Otherwise, the model will not run. This is TPB for purchasing sustainable housing. Wow. Yeah, but 2019, nowadays 2022, I think now it's like, you know, house without coffee. Oh, I want to buy it. I think, you know, house without coffee. Oh, I want to buy it. You know, if you go, the COVID-19 will disappear. I think if you can have that kind of topic, you know, that will be interesting. Okay. And this is another one, you know, that the protection motivation theory is actually this one, you know, vulnerability, perceived severity. This is and this is the theory of learned behavior, and you can extend it to like the actual behavior and perceived effectiveness. Okay. So now, if someone does not believe with COVID-19, okay, why I start with understanding of COVID-19? Because, okay, you know, right, in the past, like there was a news that someone, you know, like so many people did not believe with the COVID-19, and then they don't wear masks, they don't care, and so on, and they die, you know, like because of the COVID-19, you know, because the first thing they don't really understand what is COVID-19, and then they don't feel it's severe, they don't do certain behavior, and they, you know, then perceived effectiveness is very far. So at the end of my paper, it's actually quite strong that I say that, like if someone does not believe with COVID-19, you know, then it will not go to the perceived effectiveness, something like that. This is another one with the online food delivery. Yeah, this is during the early COVID, everyone. Online food delivery is actually quite a hot topic, but now, I don't know, now it's not really, yeah, still a hot topic, but already too many people do the online food delivery nowadays, okay? And eventually, you know what, this one, online food delivery, what factors actually affect the most, you know, I can answer that it's very critical, and then it's very to the point. You know, is what? Hedonic motivation, information quality, the price, and the promotion. It's not the how good the software, you know, it's not like how ergo friendly the software, it's not the perceived usefulness, because people already get used to it. So if you're the, if we are the boss, we are the owner, or we are the investor, don't invest on those things, you know, invest more on the what? The promotion and the, you know, the promotion and the, you know, try to affect the hedonic motivation of the person, not like to making it like, oh, let's make the application more beautiful. It's useless. Okay, because I prove it, you know, this one, what makes people like is actually not the perceived usefulness or like you know, of the app, because we already know why information quality in here is good, because the information quality is actually related to the information of the promotion itself. Okay, so if we are the developers, you know, I tell, this is one of my best papers actually, one of the high citations, I tell it very strong that it's useless if you are the developers and you only try to promote, oh, your application should be good, should be tested like this one. No. You do more promotions and better information quality. You know, that's the key. This is another model. We call it UTA, UT2. You know, another. But don't worry, everyone. When you study consumer behavior, you will learn about this model. This is actually a basic AUT2. There is hedonic motivation, price, value, habit, and so on. Okay. And this is my publication about the surf qual, okay, surface quality. Okay, this is very typical of the surface quality, consists of the tangibles, reliability, responsiveness, assurance, and empathy. And then I will publish one in the Journal of Cleaner Production. After this one, I use the surf qual. It will still minor revisions, but I will hopefully will be published in March, in the Journal of Cleaner Production. It's actually about the surf qual, surface quality. This is a very typical consumer behavior that perhaps everyone can do, in this class. Okay. And then this is just another publication about the online, drive-through. Okay, drive-through fast food. Okay, what factors actually affect the repurchase intention, in the drive-through, the drive-through fast food? Because in the Philippines, we have Jollibee. Jollibee is like the McDonald's of the Philippines, very famous. Okay, so we did that kind of study. Okay, we can do if everyone is interested in this kind of topic. Okay, so I'm quite diverse. Okay, you can do with the disaster related, with the consumer behavior, or if you would like to do with the technology acceptance, that is actually I'm quite okay with those topic. Okay, but of course, if you would like to do like, oh, I would like to do purely human factors and ergonomics, yeah, that is also okay. Then this Saturday you will know what is ergo in a different level. Hopefully, everyone still enjoy human factors and ergonomics. Okay. And then I use Amos, but don't worry. If you study consumer behavior with Dr. Satria, he will explain with Smart PLS too. Okay, so you can learn both. Okay, how to use Amos and how to use the Smart PLS. I think that will be okay. Now, everyone, this is actually the thing. Let me just finish in 5 minutes. Okay. Okay. So someone asked me what is the difference between the Scopus journal and Sci or SSCI journal? Okay, so it's different. Okay, everyone. The level of publication is actually very different. Okay, from the first one is actually just a national conference. The second one, perhaps a national journal. Just like Tanatorn. Tanatorn. You like the national Thai journals. Sorry, okay, but
yeah.
Sorry, okay, but if you want to do research collaboration with me, I'm not going to publish in a national Thai journal. I'm sorry, okay. Next one, okay, there is an international conference. There's this Scopus Index, okay. If it's go to little bit higher, we call it non-SCI journal or like Scopus journal, okay. So in here, everyone, in the Scopus journal, when they reach a certain index, a certain value, they go to the highest level. That's what we call SCI or SSCI journal. So not all the SCI journals, sorry, not all the Scopus journal is actually SCI journal. You can check it. It's actually in here in the JCR, All Clarify Analytics. Okay, if those journal is actually there is an IF or like impact factor, and then it's actually registered in this one, that is the SCI or SSCI journals. Okay, and in order to graduate in Mapua, you have to publish this one at least 2, and then as the first name. Okay, as the first name. Okay, don't worry, as the first name you can have the double affiliation. Okay, I know that some of you are the faculties, so you can get the double extra incentive from your university. Perhaps you can have it as a double, but the first affiliation should be from Mapua because you are studying for your doctoral degree program. Okay, so at least you have to have 2 SCI, SSCI index journals in order to graduate in the Mapua doctoral degree program. Not just Scopus journal. Okay, it should be in here in the JCR. Okay, Pak Hendy, any questions?
Yeah, can I assume that every journal listed in database of Clarifate means this journal indexed by SCI?
Yes.
Oh.
So not always. Sometimes the open access is still SCI. Some of the open access still SCI. Yeah. Some of the non-free journal. Some of that is actually this one. For example, this one. This one. MDPI is actually very famous with the price is actually very expensive. Okay, this one, my publication, I spent around 2000 total, I think 2000 CHF, I think around I think around 2000 US dollar for this one. Yeah, very expensive, 2000 US or even more than 2000 US dollar this one, but all 100% paid by Mapua. Mapua pays this one, a publication. Okay, but of course, for example, let's say the free journal, like the disaster risk reduction, like this one, some in this journal, for example, like this publication, it's free, so I don't need to pay anything for the this one is free, and then this is free journal, so I don't need to pay anything for this one. Okay, but for this is also free, of course, but if you publish in MDPI or open access, it's actually there is a fee, and then don't worry about the support. Actually, the university will support that one. I already asked with the director of the funding, and they say like, oh, just go, Sir Yogi, just go, you don't need to think about that one. Just as long as you can publish that one, we will try our best to provide the funding for the article processing charge. Yeah. Okay, but let's try to publish in free journal first. Let's try first. Yeah. So for me, I will try to achieve in here first. Then if it does not, from the top Q1, if it does not work in Q2, Q3, Q4. Sometimes I got like 15 rejections until the paper got accepted, but still Sci, but I'm recording this one. Oh, later on, after I stop the recording, I'll show you some of my folders that I got several rejections, but eventually, got accepted. So yeah. Okay. Any other question? Bu Fuji, any question, Bu Fuji?
Yeah, Pak Yogi, is there any minimum numbers of variables that we can use in our dissertation?
No, no, but of course, like no minimum number of interesting questions. Minimum number of variables. No, there is no minimum number of variables, but of course it cannot. Usually integrating two theories is actually usually my students integrate two theories. Yeah, usually try to integrate two. Thanaton, how many theories you use? I forget. 3, 2.
Huh? Again, please.
How many
what?
how many theories you use in your model? I forget. I even forget your model.
3.
Oh, 3, right? Okay. So yeah, 3. I remember. Yeah, some. Yeah. But even 3, Pak Hendy, is, I think the total is actually less than 10, right? Thanaton, I think less than 10 variables, right? Less than 10, right? The total of the Latin. I forget.
Yes.
Less than 10. I think just less than 10. Yeah.
Yes.
Less than 10 variables usually. Yeah. Pak Fliska? Pak Fliska, any questions? No.
Yeah.
Any questions?
No.
Okay.
I feel great tonight because I met a lot of people who are coming on the same page. We are going to publish 2 papers. Okay. Yeah.
Yeah. Don't worry if the senior high school can do it. What about us? We can do it. And in the past, I felt like yeah, that is insane and so on. But I feel like no, publication is like create for me. Okay, publication is like, because my mother is in the past, my mother used to be a tailor. So every time when I explain about a paper, I always talk with my mother like, oh mom, imagine I'm creating a garment or clothes, like I'm making like a costume, like, or like a like, let's say like a clothes. Okay, then the details of the clothes will sell it. Okay, so, and that's why, like, just like the fashion designer, they will ask what's new, what's interesting in your model, what is what is good? What is new in your model? Is it old-fashioned? What is new thing? Is it the new because of the design, new because of the materials, new because of that one, and so on? So, yeah, I always tell my mom. And then if you give it to show to you try to sell it to to the A fashion week. If the A fashion week dislike it, then you go to the B fashion week. You don't try to please A fashion week. I mean, if they don't like it, it's okay. Then let me try to submit to another journal, something like that, until it gets published. So yeah, basically it's just the way. And research for me is all about the time. Yeah, the time. So it's don't worry about us. All the faculties in the Mapua PhD program, we are very good. We don't say like, oh, this is not a dissertation, this is not a model, this is bad. So no. There is none of us. We will say we are very. I would like to say supportive. Okay, the environment. But even so, it's still difficult. Yeah, like Tanatorn, how many rejections you face? Tanatorn, how many rejections you face in your life?
Around 15.
Really?
Around 15.
Okay, but it's total, right? Total, all of the papers, right? But you're still alive, so so, and then the final defense is just very fun, really. You know what? It's just so much fun. You can ask Dr. Artin, the first graduate. The oral defense is pretty happy and then pretty supportive, and we just laugh all the time but it took 2 hours, more than 2 hours, I think. Yeah, but even so, it's just a happy 2 hours. Okay, so this is my common tips, okay, for everyone. Start with something that you are passionate about. Don't force yourself to do something that you don't like. Okay, so up to you. For example, if someone like if you don't like ergo, then don't force you to like ergo, or like the same thing with if you don't like data mining, don't try to force yourself with the data mining. Okay, but Tanatorn, I'm forcing you to do data mining, right? Sorry, okay. I mean,
not at all.
I mean, we are learning together data mining. Okay, don't worry about that. Okay, and determine the trends is actually quite good because try to see, and sometimes the idea is very unique. I published one paper with the milk tea, even just milk tea. I published Q1 journal, everyone from senior high school, because like those students like came to me and then say like, sir, I don't have any topic, and then I also do like, oh, okay, if you don't know any topic, then what is your hobby? And I like eating, blah blah blah, and so on. And then I ask, oh, what do you usually drink, and so on. Oh, sir, I like drink milk tea. And then I say like, why don't we do study about milk tea? And then we publish it. We publish about the and some of my students, they like planting, the plant, the planting, they like the selling the plant and so on, and it becomes a hobby. And then like, oh, why don't we just use that one as a topic of your your research? And then sometimes but for me, I always concern with the disaster. So every time before the disaster, I always try to distribute questionnaire, and every time after the disaster, I always try to do another questionnaire. Okay, because I do concern with the human life, and because my expertise is human factors and ergo. So I'm not born to be in the consumer behavior, but because of this COVID, I have to shift a little bit because everything is like people do the consumer more into consumer behavior. Okay, but I do concern with the disaster. That's why I publish more in the macroergonomics that are related to the disaster. So like Taal volcano, when Taal volcano erupt, the ash reached my house, in my window is like full of the ash when I was in the Philippines. Okay, so if there's a disaster, you always see there is perhaps an opportunity to see what we can do as a human to make it to reduce the impact. Okay, and then reputable advisor is actually, don't worry, with the Mapua's faculties, we are actually quite strong, with a strong publication background. All of us, we publish in a Q1, and then we have different specialties. Okay, so it's up to you. Okay, you can choose financial engineering, you can choose data mining, you can use the optimization, you can use the advanced supply chain, with the advanced supply chain optimization, with the meta heuristics. There are so many big things, in industrial engineering. Okay, so choose which, among us, will be who will be your advisor. Okay, and just do it constantly every day. If you just do it like once a week, then all of a sudden you feel like, my God, my friend already published too. Then you have that kind of like pressure, and oh, my friend already published, and so on. So yeah, perhaps that is I think. Okay, and one thing is like, for example, you will ask me, can you use your undergraduate thesis to be your publication? Yeah, why not? For me, I'm not the typical person who will block everyone to not doing that one. Why not? Because for me, in the research, I learned from all the top professors in my advisor and my co-advisor. Okay, why they are so successful and they can publish like 20 journals in Q1 in 1 year. Because they constantly keep the idea. If it does not finish from one student, when the student graduate, they will send it to the next student and continue and so on until it becomes a very beautiful paper. So this is like this one. See, like student A plus B, student A, B, C, and so on. So when you read the paper, it looks like so rich. When I say like, yeah, I know it cannot be done by I'm not in their level yet, because for me that doing those kind of the experimental things, well, during this COVID, it's almost impossible to do the the human performance experiment like that one. But I'm trying my best, for my undergraduate thesis. I'm not in rush to sell it into a conference too quickly, because I would like to make it into a journal. But if it's not there yet, then I will just like, okay, let's just hold a little bit and then try to fix it and submit it to a journal. So we are not in rush, so in publishing to like, because for us is for me somehow is such a waste. If you have a very nice idea, you sell it to a conference. Okay, because most of the conference, they will accept the paper. Okay. This is one story actually. Okay, from the same data, everyone. From the same story that I've done, in the past. Okay, see, I have a concept and I continue to publish that. I continue to publish again. I continue to publish again. So this is some of the stories, that I've done with my professors. How my advisor trained me to be consistent with what I am doing. For example, like okay, now I have one actually quite consistent. That is actually disaster risk reduction. Okay, from typhoon, volcano, earthquake, I will do tsunami and landslide after this one actually. So the continuity is actually very important. Okay, yeah, I'm trying to learn new things like service quality, okay, and then like consumer behavior. Yes, new, but my core is still there. So this is actually the thing that everyone needs to learn, doing like slowly. But of course, in some universities, for example, some of my students, they try to do this, but they got the Tanaton, you got the in Thailand, you also got the in your previous university. You wanted to do this, but other faculties disagree with you, right?
Yeah.
Yeah, because they say like, oh yeah,
So bad.
oh, you have to publish that one in a Scorpius as soon as possible for the university, blah blah blah, and so on. Yeah, I know that feeling. So that one is difficult, but I am very lucky that all the things that I'm fighting is actually supported by Mapua. So every time when I have the idea, I try to talk with the top one, the top person, and then the top person is actually very supportive in terms of the publication related like this one. So they say like, yeah, okay, yeah, I do understand about you. I know like using coaching 6 months is very difficult to publish journals. Then even so, then why don't you just try to start earlier, like 1 year earlier before you, and then that is the thing actually that I am doing. But now I don't have the undergraduate students anymore. I don't have master, only one student, because she's begging me to be her advisor, because I'm so I have to shoulder the PhD program, because we have so many. I think the total now is almost 20, I think, the PhD students, and then 3 students will graduate. Sorry, I think 5 or 6 will graduate this year, at the end of this year, or even more. So if we have a constant public, we can constantly publish the students, then it will be good for the reputation of the university, because of people actually trust that wow, you can less than 2 years you got a doctoral degree with the top journal, like because the publication is in here, SCI, SSCI. So people will not question. Either you go to Harvard, you go to MIT, they publish in the same journals. Okay, so same. Yeah. Okay, so yeah, for if you would like to do the SCM related, okay, get ready to distribute something online. And usually I will ask Tanaton, how many data you have? 800, I think. Yeah, right. 800, right? Yeah.
Yeah, 800 in this research.
Yes, but you can split it into two or three publications. Two publications. Yeah. So if you have the using the multivariate data or SCM data, usually I will ask the student to get 300, 400. Usually that's the number that I ask for the students. Okay, if you can get that number, then usually is the result will be good. If it is less than that one, usually it's difficult. Yeah. So I always try to find a way how to do it. Yeah, I know I've done some studies in Indonesia. It's quite difficult to get the data from the online like that one. But in the Philippines, in 1 week I can get more than 1,000 using Facebook only, because the Philippines is the Facebook country. So in Thailand, Tanaton, what did you use? Facebook also, right? Yeah, right.
No, just Line.
Oh yeah, Line. Yeah, you use Line. I remember. Yeah, you use Line to get those many respondents. So different countries have different ways how to collect the data, but at least that is the number that usually is quite successful for research. Okay, so yeah, don't worry about that. We will do it slowly, but I think everyone needs to think, what will you do in this doctoral degree program? And you can chat to me privately if you if you want to discuss with me privately, you can chat to me privately. Okay, so I will give you my number, everyone. WhatsApp, my WhatsApp. Okay, so and then for my Line, if you use Line, okay, if you email, okay, so yeah, that one. Okay, so those three, you can just contact me directly. What will you do in this PhD program? Okay, that's all for the first day. How is that, Handy? So far, so good. First meeting already what? Already, you still can take it, right? This is still first meeting, but I mean the next meeting, I hope that you can enjoy. But don't worry, if you feel like, oh, this is already too details and so on, then I will just slow it down, like this is the first meeting, but again, this is PhD, right? So what do you think, Pa Andy, tonight?
Yeah. Yeah.
Speechless.
Thank you,
yes,
by the way, Pa.
Speechless.
About our publication in SCI index, we should make like another research topic, or we can proceed.
No, you can
part. Yeah.
You can, actually that you can make. Usually, I will require just the final exam. In the final exam of my class is just, you can, up to you how far you go. If you only can go, I only can finish the introduction, but yeah, it's okay. It's okay. I mean, I'm not forcing everyone to I know everyone is busy, everyone has their life and so on. So usually the final exam in my class, it can be one of the 2 publications usually. So as long as you have 2, it's okay. You can publish. You can graduate. Yeah. Yeah. Just try to think what you like. Okay. Pak Filska, any shocking, any short in bread? We call it COVID-22. COVID-22 is the PhD. And so So any comments?
Yeah, I think we need to prepare our mentality before enrolling, even before enrolling into the PhD program. So this shouldn't be a surprise for us, because you need to hike, you need to go, yeah, in a steepest way, yeah. Maybe 2 years. This is maybe my personal target, 2 years, or maybe at most 3 years.
No, usually just less than 2 years. Most of my students usually less than 2 years. Yeah.
Okay, so this shouldn't be surprised, because we need to prepare ourselves even before enrolling into this course.
Yeah. But do you think it's shocking? It's hard? Well, I say it's challenging, yeah, but I don't say it's
Yeah, that's good.
it's not drama, you know. I mean, there is no drama. I mean,
I will say this is challenging, not hard.
Yeah. I mean, yeah, it's hard because of the level of difficulty is there. So yeah, I do understand.
Sure.
Yeah. Tanaton, do you feel stressed? You almost graduate. Do you feel stressed? May I know?
Yes.
Why?
I'm afraid about the 7th committee in my dissertation.
Hey, you attended Dr. Artfin's on defense, right?
Yeah.
Yeah. Do you think scary? Oh, I don't think it's scary. Is it scary?
Not at all. But Dr. Artfin is genius, and me just normal guy.
It's okay as long as you graduate, it's fine, right? I mean, and then you already finished the 2 Sci, so don't worry. We will not. We will just be happy, for the But anyway, Yoshiki will graduate first. Okay, you will be the 3rd one. Bufuji, any shocking news? Any short in breath? Any?
Thank you. Maybe that is for challenging for me, but I am interested and I am happy for this. Thank you.
Okay. Okay, so I think that's already very late. Let me just stop the recording.